Hi, we're going to do a session on trigonometry, and we're going to be looking at trig identities. We're going to focus on a question from the November 2023 NSE finals, and we start off with question 5.21 that says, prove that cos to the power 4x plus sine squared x times cos squared x all over 1 plus sine x is equal to 1 minus sine x. So immediately we're going to start with our now, if we look at the left hand side, we have on the numerator cos to the power 4x plus sine squared x, and we have a cos squared x. So what we can see on the numerator is that we have a common factor which we're going to pull out, and that is cos squared x. And if we take out cos squared x, then we have cos to the power 4x divided by cos squared x is cos squared x. And if we take sine squared x times cos squared x over cos squared x, that will cancel off there, and we would get sine squared x. And your denominator will stay as it is, which is 1 plus sine x. Now, if we inspect the numerator, we have cos squared x plus sine squared x, which is actually equal to 1. So we can replace the numerator with cos squared x times 1, which is cos squared x, that won't change, all over 1 plus sine x. Now, if you look at the right-hand side, the right-hand side is 1 minus sine x. So that's where we want to go. That is our destiny. So to get that, we're going to change cos squared x. So if you remember your trig identities, that sine squared x plus cos squared x is equal to 1. You would have studied that in grade 11. So making cos squared the subject of the formula would be taking your sine to the other side. We would get 1 minus sine squared x. And that's what we're going to replace our top with. 1 minus sine squared x all over 1 plus sine x. Now you'll notice 1 minus sine squared x on the numerator is actually a difference of squares, which we can factorize to be 1 plus sine x into 1 minus sine x. And our denominator stays as 1 plus sine x. And then you'll notice we can cancel off for 1 plus sine x, which is actually equal now to the right-hand side. And that is how we managed to prove that. Okay, we're looking at the next question, which says, for what values of x in the interval 0 to 360 is cos 4x plus sine squared x cos squared x all over 1 plus sine x is undefined. Now, you remember that a denominator cannot be 0. If a denominator is 0, then this will be undefined. So, for it to be undefined, the denominator in this case, which is 1 plus sine x, will have to equal to 0. And we're going to solve for this. That will give me sine x to be equal to minus 1. So, using our calculator, we'll type in shift sine 1. That will give us our reference angle to be equal to 90. Now, so remember that sine is negative in quadrant 3 and 4. And the angle formula is 180 plus the reference angle, or 360 minus. And if you take 180 plus 90, that'll give you 270, or 360 minus 90 is 270. So therefore our x is actually equal to 270. My pen is just seems to be running out of electronic ink. Just try to get that to work again. Okay, and there we have our x to be 270, which satisfies the domain of 0 to 360. The last question, 5.23, that we want to focus on now, says write down the minimum value of the function defined by y is equal to, we have the entire expression. Now remember, in question 521, we proved that using the trig identity, that's actually equal to 1 minus sine x. So we can actually work out what is the minimum of 1 minus sine x, because this entire expression is equal to that. And we know that the sine graph has a minimum value of minus 1. I mean, if you look at your sine graph, quickly, I just want to draw a sine graph for you. And there's our minimum value at minus 1. Okay, so 1 minus minus 1 would give you 2. Therefore, that would be incorrect in my explanation, because and that would be incorrect, and I want to show you why. So to understand this, I'm looking at the sine graph and not the negative sine x graph. So what we actually have to do here is quickly understand what is your negative sine x graph. Now very quickly, I'm going to give you a sketch of that to understand. So if we look at a negative sine x graph, it goes the other way, and it should be looking something like that. So the minimum value of a minus sine x graph is actually negative 1. And this is a plus 1, which means we're shifting the graph 1 unit up. And if we shift the graph 1 unit up, that brings us to a minimum value of 0. I hope that makes sense to you.